So what we can do now is we can take those 5 equations that I've labeled in previous videos and we can sort of plug them into each other, rearrange, combine them in certain ways in order to get alternate forms of the equation. And why do we want to do that? Well, maybe for a particular problem, we only have certain information available, so one form is going to be easier to work with than another. So let's start by plugging equations 2 and 3 into our previous equation 4. So equations 2 and 3 were for our half power frequencies, so these were equations for omega 1 and omega 2. And this was the equation for our bandwidth. So basically we're plugging in omega 1 and omega 2, those big, long, detailed equations, into our bandwidth, which said B equals omega 2 minus omega 1. So if we do that, we get that our bandwidth is going to be equal to R divided by L. And so let's call this equation 6 because we're actually going to use that in order to come back and readjust our equations 2 and 3. So now let's say we're going to use a couple equations in blank and blank. Sorry for sort of skipping around here. It's just going to make it easier to not have to change as much between colors. But basically if we use equations 1 and 6, which is the one we just found, and we plug that into 2 and 3, and so just as a refresher in terms of what these equations were, 1 was our equation for our resonant frequency omega naught. 6, of course, we just defined here above for our bandwidth. And then again, 2 and 3 are going to be our omega 1 and omega 2 equations. So we can get different forms for those omega 1 and omega 2 equations. We get that omega 1 is equal to negative b over 2 plus the square root of quantity b over 2 squared plus omega naught squared. And then our omega 2 is going to be the same, but we have b over 2 instead of negative b over 2 out front. So b over 2 plus the square root of b over 2 squared plus omega naught squared. So let's box these in and give these guys some numbers as well to be consistent with the notes. So these are 7 and 8. Okay, so let's go a little further and let's see if we can use 1 and 5 and plug that into 6. Well, actually 1, 5, and 6. So we're going to combine 3 equations. Okay, so we're taking equations 1, 5, and 6. And so again, our 1 was our resonant frequency, our 5 was our bandwidth, our 6, 5 was not our bandwidth, 5 is our quality factor, Q, and 6 we defined above, that was our alternate form for our bandwidth. So if we combine all of those together, what we get is our resonant frequency is equal to B times Q, so bandwidth times quality factor. So let's call this equation 9. And then one other one that I'm going to explicitly label here, just to be consistent with the notes, we had written it previously, but we had written that our resonant frequency is equal to the square root of omega 1 times omega 2. And so I'm just labeling it here to be consistent with how it's labeled in the notes. So we have that as number 10. So again, these alternate forms might be useful depending on what information is available. One important thing to keep in mind, anywhere we see beta where we're plugging in a beta, so for instance here in these equations, or down here for finding our resonant frequency, any of these equations where we're plugging in beta, we want to plug in beta in units of radians per second. So for instance, if you have a plot and the frequency scale is in hertz, we want to first convert that to radians per second before plugging into these equations. One other thing we want to take a closer look at is let's consider this equation 9 and the implications that it has. So what we can see is that if we have a fixed, so let's say from here, if we have a fixed resonant frequency, then we have sort of this inverse relationship between B and Q. So I've tried to draw this out here in the plots. but if you look on page 630 in the textbook, you can maybe see it a little bit clearer. But what we have here is, for instance, we have this green curve, which would have a really high Q value. So let's say this is Q1, and so our Q1 is going to be high because it's a very sharp resonant peak. But we notice down here that we have a bandwidth that's relatively small. So let's call this B1. So if we decrease that peak a little bit, then according to that equation 9, we're going to now have a Q2 associated with this, and so let's call this our medium sharpness. But sort of the trade-off with decreasing that sharpness is now we have a larger bandwidth. And we can take that a step further, and we can say for this red curve, we've sort of flattened it out a lot, so we have this Q3, which is a low quality factor, so not as selective, but on the other hand, we do get a larger bandwidth associated with that. So that's sort of an inherent trade-off related to a circuit between the bandwidth and the quality factor. And so a similar idea that we'll talk about in a later class is this idea of our gain bandwidth product and how it's constant for a given circuit.